Next one. It says, given that the line y equals negative 2x plus k is tangent to this graph, find all possible values of k. All right, so we're talking about tangent. And when we're talking about tangents, we tend to talk about the derivative. The tangent is, when we're talking about the tangent, we typically talk about the slope of the tangent, which is your derivative. So you could look at this equation and you're like, how on earth would I find all the values of k? I'm just told that it's tangent to the graph. Well, you are told more than just that it is tangent to the graph. You aren't missing all of the pieces of this equation. You're missing only one piece of the equation. So why did they give you the slope of the tangent line? So since they gave you the slope of the tangent line, that means that it's when your derivative is equal to the slope. If the slope of your tangent line is -2, and you're trying to figure out, okay, where would I have a slope that is -2? You can say, okay, h prime of x equals -2, where? Where is my derivative, which is the slope of the tangent line? Where is my derivative equal to -2? They gave you that -2 on purpose. So go back through and, like a treasure hunt, look through exactly everything that's been given to you. Why do they want you to solve for k? And what about this is important? Well, the tangent we typically care about the slope of. Oh, they gave us the slope. So we know that, and we can go ahead and use that to move forward. This is tough. All right, so we want to know where the derivative is equal to 0, or sorry, equal to -2. Plotting on our graph, -2, that would be like somewhere down here, right? -2. So we need to figure out where is it equal to -2. Remember that when we are tracing, we can type in like -2, but it brings us to an x value of -2 and not a y value of -2. And so in order to figure out where would the graph be equal to a number, when is y equal to this, we need to graph another equation, which is -2. When we graph that other equation that is -2, it shows us this is a point that has a y value of -2. And then over here would be a point that has a y value of -2. I'm going to zoom in because you can imagine that that situation right there is a little bit tricky. So because I ran into this issue when I went through this problem on my own, I had to like erase and redraw a bunch of things. And my calculator kept freezing up on me because I kept on switching between graphs because I couldn't grab the right graph for the intersection. And so I would really recommend with this situation, just because I went through the pains for you, to make sure that you're zoomed in on that. So finding that intersection will be a little bit easier. If you do graph trace, remember that the red is our derivative. So right now I'm on the original. If I scroll down, I'm now on the black, but I could scroll. Whoop. Sometimes it locks in, but in this case it didn't. So I was going to say, hey, let's trace and have it lock in. It didn't work. So what we're going to do instead is we're going to hit menu, analyze graph, and we want the intersection. Which graph? We want this one. And this is what happened last time, is that this little clock has to rethink every time you switch which graph you're hovering over because it's got a lot of information going on right now. So zooming in will help prevent that. So if you didn't zoom in and you're running into that right now, I would recommend zooming in. So the red graph is our derivative. The black graph is our y equals -2. My calculator is really not liking me right now. It's going to really glitch and lag. So we just got to be patient. I'm to just barely the left of it. Hit enter on the lower bound. It's going to ask me for upper bound once it's ready. So I'm going to move just to the right of it and wait. And then press enter. And there we have it. This is one point where our derivative would have a slope of, or our derivative would have a y value of -2, which means at 3.382 on our original graph, here would have a slope of -2. Okay, so that's our first x value. That would give us a slope of -2. I'm going to go over to the second part of my graph. This intersection is going to be a little bit easier to find. If you can't see it, you can always move it. My second x value is 2.62. So these are the points on my derivative, which would give me a slope of -2. Okay, so take a step back because we're not done yet. The question was, given this equation of the tangent line, what could the values of k be? So realize we found two x values that would give us a slope of -2. So we could plug those x values in for x here, but we cannot plug -2 in for y because -2 is not our y value. It's the slope of our y value. So we have x values we can plug in. What are the y values? Our y values are found from the original equation, which means you need to go in and find out what, plugging in those x values, what y value do we get here? So that would be going back to, in this case for me, I'm going to zoom back out. For me, that means going back to the blue graph. What y value coincides with those two x values? You can find those on your own. The y value for the x value of 0.382 would be -1.85. If you trace or value for TI-84s, and I type in 0.382, enter. Oops, I'm on black. I need to be on blue. There we go, -1.85. Then I also need 2.62. Press enter, and the answer is 4.85. Okay. Oh, oops. There we go. So we have the y values and the x values, the point. So this is on derivative, right? This is slope calculations. The point 0.382, -1.85, and 2.62, 4.85. These are on original and have an instantaneous rate of -2, which means at these points, we would have a tangent line that has a slope of -2. So if we know an x value and a y value that goes with this slope, then we can solve for k. We have two different points that would satisfy that on the original graph. And so we're going to have two different equations, which means we're going to have two different values of k. All possible means 2 in this case. All right, so I'll do one with you, and then I'll have you do the last one on your own. We have the y value, so we've got negative 1.85 equals negative 2 times 0.382, plugging in your x, plus k. Multiplying those out and then adding this to the other side, we get negative 1.09 equals k. And that is one of your answers. I would like for you to go ahead and solve for the other value of k using our second point. So we go ahead and plug in 4.85 equals negative 2 times 2.62 plus k. Solving for that, you could use numerical solve if you want to. We get 10.09 equals k. If you would like, putting those entire equations together, that means we have y equals negative 2x minus 1.09, or y equals negative 2x plus 10.09. We could graph those if we wanted to be crazy. I'm going to take away the negative 2 and actually make it negative 2x minus 1.09. So now I'm going to take a look at this tangent line that has a slope of negative 2. Then I could also graph my other tangent line, negative 2x plus 10.09. And you can see this parallel line, because they have the same slope, that goes through those points there. So that's what we just found, was the 2 points that happen to have a slope of negative 2. Pretty cool. Really hard, but pretty cool. Again, I would recommend, if you wanted to, if you're like, I didn't understand anything that just happened, grab a piece of paper, a blank piece of paper, and listen to it again and see if the second time you listen through it, does it make a little bit more sense. And the play posits can let you go through as quickly as you want after watching it the first time. All right. Thanks, guys.